Hi everyone, welcome to the menagerie. Today we're going to be talking about how carnivorous plants are able to eat insects. Whether it's by trigger hairs, sugar mucus, mini ecosystems, or microscopic vacuum chambers, we're going to be talking about 4 different carnivorous plants and how they trap and digest insects. I want to apologize in advance. I'm a little bit stuffy, so if I'm talking weird, that's why. But jumping right in, the first plant we're going to talk about today is probably familiar to you, and it's the Venus flytrap. The traps on these plants are actually just modified leaves, and they photosynthesize like every other plant. They just happen to also be a mouth and a stomach. Flytraps can also experience indigestion when they eat too big of a meal. When they eat too big of a meal, their digestive juice essentially just overfills their trap and ends up burning them, and the whole trap dies back. Tummy aches make me feel like I want to die as well. I'm sure my anxiety people can relate. Another cool thing about Venus flytraps is they know how to count, at least to 2. On the inside of the trap, they actually have microscopic trigger hairs, and the trap doesn't close until 2 of these hairs have been activated. The plant expels a lot of energy when it closes its trap to catch its food, so it doesn't really want to waste all of that energy if they're not able to absorb nutrients from it in the end. A really common misconception about Venus flytraps is that you can give them dead bugs or that carnivorous plant gel that's targeted towards new people to the hobby. But this really doesn't work in the end. Flytraps actually make sure their prey is alive by sensing movement inside the trap. And after a while, if they don't feel any more movement, the trap will just reopen. This is actually the reason why you shouldn't stick your fingers in the heads of Venus flytraps, because it takes so much energy to create that motion, so they're just wasting all of that energy for nothing. This video shows a black widow spider crawling all over the trap, and it doesn't actually trigger the trap until its legs touch 2 hairs. Then you see the spider briefly stop moving and start twitching again. And only when the plant starts sensing movement does it fully shut. The digestive juice breaks down the nutrients from the insects, and when the trap opens up again, the hollow exoskeleton is all that remains. The next plant we're going to talk about is Drosera, more commonly known as Sundews. The specific one in this video is Drosera capensis. These carnivores lure their prey into sticky traps baited with polysaccharide mucilage, sugar mucus. This adhesive is produced by glands on the leaf surface, which also produce digestive enzymes to absorb nutrients from their prey. When live prey lands on the sticky trap, these tentacle-like glands bend towards the insect to prevent it from escaping. This also exposes the insect to more digestive fluid. And like fly traps, they leave behind a husk of their victims. Our next carnivore for the day doesn't look like much at first glance. It actually kind of looks like seaweed, to be honest. But aquatic Utricularia, like this Utricularia macrorhizos, actually have traps for catching insects. All of those circular modified leaves, or bladders, are designed for trapping and digesting prey. Because they have tiny aquatic traps, instead of insects, they eat a variety of freshwater microorganisms. At the entrance of the trap, there are these hair-like structures that sense when something's approaching. And these bladders are kept under negative pressure, which creates tension inside of the trap. When the trapdoor is triggered, it flips inward, releasing all of that energy, which essentially just creates a microscopic vacuum chamber. When it creates this vacuum chamber, all of the organisms and water around it get sucked into the trap. I'm gonna play a clip of what this looks like, but don't blink, you might miss it. Inside the bladder, digestive enzymes break down the microorganism so the Utricularia can absorb the nutrients. The last plant we're going to talk about today is Sarracenia, and I think these guys are really interesting because how they digest their prey is different based on what type of Sarracenia it is. For easier understanding, we're just going to call these the tall ones and the short ones. The taller species of Sarracenia produce their own digestive enzymes and take care of the whole process themselves. Bugs fall in the pitcher and their digestive juice breaks down nutrients from the bugs for the plant to use. And believe me when I say they catch things you didn't even know lived in your yard. Sarracenia purpurea, or the shorter pitcher plants, do not produce their own digestive fluid. If you notice the larger ones that do make their own digestive enzymes, their lid actually blocks the top of the trap. This keeps rainwater out of the trap because it's not needed and it actually dilutes the enzymes the plant already made for itself. On Sarracenia purpurea, the lids always remain open and almost funnel the rainwater down into the pitchers. This makes up for its inability to make its own fluid. Because the trap remains open and insects could easily fly away, it actually has downward facing hairs to encourage bugs to fall down into the trap. Rainwater alone isn't enough to properly digest insects once they fall into the pitcher though. To take a closer look, I took some of my Sarracenia's pitcher fluid and put it under a microscope. Here you can see there is actually an entire ecosystem of its own living inside this plant. Larvae and other microorganisms live inside the pitcher and break down prey for the plant to get nutrients. This is a great example of a symbiotic relationship in nature. The pitchers provide the conditions for the microorganisms to thrive, and the microorganisms supply the plant with nutrients. I had a lot of fun filming this video about some of my favorite plants, so I hope you enjoyed watching. This is a look into next week's video where I'm going to be explaining the science behind variegated plants. Thank you for stopping by, and I hope to see you next time.